Welcome to EDU World Space.
So in this question, we have been given the angle of rosette that is equal to 45 degree, right? And the value of the strain, that is epsilon sub A, it's equal to 475 into 10 raised to power negative 6. And the um, epsilon sub B, that is equal to 250 into 10 raised to power negative 6. And gamma sub C, that is equal to negative 360 into 10 raised to power negative 6. Right now, I'm going to follow the example 10.8 because it's similar to this question, and that is how the author intended to do it, right? So that is why I'm going to use that example. Now, we're going to use the equation 10.6 to find out the strain components. So now, what are the strain components? They are the strains that are acting in the x and y direction, and the strain that is epsilon sub xy, right? Now, since the rosette is arranged in a 45-degree pattern, right? So we can say that the strain that is acting in the x direction is equal to epsilon sub a. The strain that is acting in the y direction is equal to epsilon sub b, and the strain that is acting in the uh, xy direction, right? So that is equal to 2 times, right? Sorry, this was z. 2 times epsilon sub b negative the sum of both the strains, right? Now, what we're going to do is that we are going to substitute the values, right? For these three equations. So, strain acting in the x direction is equal to 475 into 10 raised to power negative 6. Strain acting in the y direction is equal to negative 360 into 10 raised to power negative 6. And the strain acting in the xy direction is equal to 385 into 10 raised to power negative 6, right? Now from here, what you're going to do is that you need the radius for in order to build a Mohr's circle, right? Now it's up to you if you want to build a Mohr's circle or not. Um, it's not necessary, but I'm going to build it. So we have the expression for the radius, right? That is the difference of the strains divided by 2 whole square plus the square of the share of the strain divided by share strain divided by 2, right? So calculate it and you get that the radius is equal to 459 into 10 raised to power negative 6, right? Now we are going to finally um, find out the origin of the axis using the equation 10.13, right? So that is equal to the average value of the strain, right? So that is basically the sum of the strains divided by 2. You have the values, plug them in, and you can find it out by yourself. That it is equal to 57.5 into 10 raised to power negative 6, right? We just need to draw the Mohr circle now. Now, as you can see over here, this is the A point where all this um, state of strain is occurring, and we need to measure the angle from this point, right? Now, with the help of this circuit, it's very easy to find out the principal strains, right? So the expression for principal strain is OC plus R, right? You have the values, just plug them in. It's equal to 517 into 10 raised to power negative 6. And then the other principal strain is equal to OC negative R, right? So that is equal to negative 402 into 10 raised to power negative 6, right? So this is the end of your solution.